Number 11 here is another volume on a base problem. So what's going on here, guys? Our base, our concrete foundation, is a semicircle. Y is equal to the square root of 9 minus x squared. You could do a little work on that if you needed to, guys, but it tells you it's a semicircle. If I were to, let me kind of work backwards. I'll erase this in a second, but y is equal to the square root of 9 minus x squared. If I squared both sides, I get y squared equals 9 minus x squared. And then if I brought this x squared term over here, I'd get maybe what you're more familiar with. X squared plus y squared equals 9. Except that is a full circle because this is just the positive square root. This is just going to be the top half of your semicircle. And the radius of that is going to be 3, which of course means it begins over here at -3. Okay, so hopefully you guys were able to figure that out without too much difficulty right there. Okay, and that's what we're dealing with. So our base is a semicircle. Got it. Yeah. Oh, they were nice enough to tell you from -3 to +3. Now the cross sections we're drawing perpendicular to the x-axis. Again, there's that phrase, and that tells me right away this is a dx problem. So I'm going to draw one cross section here in this base perpendicular to the x-axis. And that is going to be the base, or better yet, one side of a square. So that's going to be an S right there. And how do we measure S? Top curve minus bottom curve. Well, it's bordered by this function on the top, the square root of 9 minus x squared, and technically minus, well, on the bottom, that's going to be the line y equals 0. So you actually don't need that -0 at all, and that's what S is. Okay, so now that we know that, what are we doing with it? Now again, I'm going to draw this poorly, I can tell you right now, guys, but if I wanted to try to get this right, those two distances should be about the same, and so should this. And as it passes through that point there, it should run parallel to the x-axis. This is going to be a funny looking curve here, guys, that's going to do something like that. I don't think I drew that very well at all. Oh well, that's what it should be, and that should be almost hitting there. Close enough. All right. Actually, I know my mistake, and now I want to fix it. Basically, this should go a little bit further out here and then come back like this. All right, so that's about what it should look like. None of that really matters. Anywho, what do we have here, guys? This piece right here in red, it runs parallel to the y-axis. That's S, and we are building a square sticking up in the z direction there, and our square is going to look like that. So, what do we know about squares? That the area of a square has to equal side squared. And this is what S is, represented in terms of x. So A of x is going to equal this S value squared. Oh, so it's going to be the square root of 9 minus x squared squared. This wasn't bad. And the square and the square root cancel each other out, and we just get 9 minus x squared for the area of any one of those infinitely many squares that we're drawing. So now that we've got our A of x formula, here we go. Volume will be an integral. I'll learn my lesson now, although I'm not sure I need it. Leave some room out in front. An integral, we said a long time ago, taken with respect to x. The integrand is this expression right here, and you can't do anything to clean up 9 minus x squared. There's no constant factor that you can pull out in front. Limits of integration would be the lowest and highest values of x, which go from -3 to +3. But again, I do this a lot, guys. You'll notice I'm going to take advantage of symmetry. I'm just going to integrate this region from 0 to 3 and then double my result. Always easier to use 0 for a limit of integration if you can, if you're going to do this by hand, which of course I'm going to. You guys, on your test coming up, you're going to be allowed to use your calculator here, so it doesn't really matter at that point. So 2 times antiderivative of 9 is a 9x, and the x squared gets us a 1/3 x cubed, all going from 0 to 3. Okay, so the 2 stays out in front. Let's start some brackets and parentheses now. 9 times 3 is 27 minus 3 cubed. That's 27, but 1/3 of 27 is going to be a 9. minus, and when you go to put the 0 in here and here, you just end up with 0 as well. So, I can almost squeeze this in. All right, what do we got, guys? 27 minus 9 is 18, minus 0 is 0, and 2 times 18 is going to get us a nice round number, 36 cubic units for the volume of this solid here in problem number 11.